In 11.2, we are going to look at using the law of cosines. It just adds a little refresher and a reminder. When we were using the law of sines, basically we were using it for the case where you have an angle, a side, an angle, or a side, angle, angle. If you have two angles, basically, law of sines is really good. Now there is that ambiguous case where you have a side, and an angle. Kind of want to avoid that though. So when we use the law of cosines, what we're going to use it for is if you have the case of side, angle, side, or if you have three sides and no angles. In those two cases, the law of sines doesn't work because you don't have enough information to solve an equation using the law of sines. Now the law of cosines formula, it may look a little bit intimidating. It's just based on the Pythagorean formula from a right triangle. Given any right triangle, you have a squared plus b squared is equal to c squared, where c would be the hypotenuse. That would be the longest side opposite the right angle. But remember, we're solving any triangle at this point. So it could be a right triangle, but it could be any type of triangle. This does work for right triangles though. In that case, notice that in the three formulas, they're all basically the same. It just depends on which side, which angle you want to find. The minus at the end, in the case that you have a right triangle, that would turn out to be 0 and it would go away, and you just have the Pythagorean formula because cosine of pi over 2 or 90 degrees is 0, so that whole minus portion would just go away. But again, we're working with any triangle. So let's look at using those formulas in example 1. In this case, we have a side of 15, then an angle of 124 degrees, and then a side of 20. So this is an example of side, angle, side. Now here, I'm going to go ahead and label just to remind myself what the 15 and the 20 stand for. So notice that the 20 is opposite angle C, so that would represent side C. The 15 is opposite angle A, so that would be side A. Now it seems reasonable for me to find side B. I'm going to be using this second formula because the B squared is by itself. I could use any one of the three, but since I'm solving for side B, I might as well use the second one. Less computations. I'm going to write down the formula that I'm using. I'm using B squared is equal to A squared plus C squared minus 2AC cosine of B. And now another reason why I chose this formula is because I have A, C, and I also have B, angle B. If I chose any of the other two, I would have an issue because I don't have angle A and I don't have angle C. So I always want to choose a formula where you have the most information. Our B squared is equal to, A, which is 15, so that's going to be 15 squared. I was going to write 225, but I think I'll write it all out first. C is 20, so 20 squared minus 2 times 15 times 20. And then it's cosine of angle B, which is 124 degrees. So at this point, especially if you have a really good calculator, you could just put the whole thing in, and you'll get probably about 961 for B squared, and then square root both sides to find B. I'm going to do it in pieces because I just want to remind you of your order of operations. So 225 plus 400, and then minus 2 times 15 times 20 is 600. Cosine, and I'm going to keep it as cosine of 124 degrees. And at this point, many people might want to do 225 plus 400 minus 600 and kind of ignore the cosine of 124 for now. But you can't do that because this is 600 times cosine of 124 degrees. By order of operations, you would have to do that separately. from the 225 plus 400. Now you can add the 225 plus 400 to get 625 minus 600 cosine of 124 degrees. But you don't want to do the 625 minus the 600. You have to do the 600 times the cosine of 124 degrees separately. So this is not the same as 25 times cosine of 124 degrees. At this point, I would go ahead and put this whole thing in a calculator, and I could have done it sooner. I just wanted to point out order of operations and just be careful. When I put this in the calculator, I get about 960.5157421. So remember, this was b squared. Square rooting both sides, I have 30.99, so really close to 31, which is nice because we're supposed to be rounding this to the nearest whole number. 21.8, let's see, 30.9921884, sorry. So if I were to round to the nearest whole number, which is what the directions say, round to the nearest whole number, then that would be 31. My B is about 31. There's no units, so I don't have to worry about that. And I'm also going to label this on my triangle. I don't have to, but for me, it's easier to double check and make sure that that answer makes sense. So that answer does make sense. Angle B is 124 degrees. This is going to be the largest angle because remember the sum of the angles of a triangle are 180 degrees. So clearly B is the largest angle. It has to correspond to the largest side, and it does because 31 is larger than the side 15 and the side 20. So now let's go ahead and find either angle A or C. It doesn't matter which one. I'll just go ahead and find angle A, working alphabetically. And I'm going to reuse the law of cosines. Now, it would be easier at this point to use law of sines, but law of sines tends to be not as accurate, and you may end up with an ambiguous case. So I'm going to stick with law of cosines. And I am going to find angle A. So if I'm trying to find angle A, I have to use that first formula, A squared equal to B squared plus C squared minus 2BC, and I'm trying to find cosine of A. Once I get the cosine of A by itself, then I can use cosine inverse to figure out what angle A is. So this is a difficult formula to use when you're trying to find angles because notice the cosine of A is on the side of the equal sign where it's got a bunch of other stuff that I have to figure out first. And then I have to get the cosine of A by itself. So I know what A is, that's 15. This is going to be 15 squared equal to our B was 31. Now, normally we have to be careful when we use a value that we've approximated. But when we looked at B, it was 30.99 something. So it's so close to 31 that the accuracy will be okay. Now, I would be hesitant if it was 30.5003 or something like that. So if it was 30.5 and I rounded it to 31, my answer could be off by 1 or 2 degrees. But this is fine because it's 30.99. If it was like a 30.5, put in 30.5 instead of 31. Let's see, what was C? C was 20. So this is going to be plus 20 squared minus 2 times 31 times 20. And then we're trying to find cosine of A. So I'm going to figure out what all these values are first and then get the cosine of A by itself. This would be 225 equal to 961 in my calculator plus 400 minus 2 times 31 times 20. Again, you could put a bunch of this, well, actually, it's kind of hard, right? Because you have that cosine of A. So it's really hard to put the whole thing in the calculator once. So we're going to have to do this in pieces. Minus 1240 cosine of A. So I can add the 400 to the 961. to get 1361. But again, the caution is you do not want to do 1361 minus 1240 because that's times cosine of A. So instead, what we need to do is use our order of operations to subtract the 1361 from both sides. Okay, so when I do that, I get a negative 1136 equal to a negative 1240 times cosine of A. Again, the goal is to get the cosine of A by itself. I would divide both sides by the negative 1240 to get negative 1136 over negative 1240, and that's equal to our cosine of A. So now the negative over the negative, that's a simple change to positive. I'm not going to bother reducing the 1136 and the 1240, that fraction. I'm not going to bother reducing it because at this point, I'm going to use my calculator. So remember, to get the angle A by itself, we're going to do cosine inverse. 1136 over 1240 in our calculator. When we do this, and unlike sine, we're not going to get a choice. Remember, we had an ambiguous case with using law of sines because when you look at the sine function, if you put in a positive value, you're going to get an angle in quadrant 1 and quadrant 2. But cosine is different. Cosine is positive in quadrant 1 and negative in quadrant 2. So if you put in a positive value into cosine, you're only going to get that one value in quadrant 1. If you put in a negative value, you're going to get that one angle in quadrant 2. You're not going to have a choice. There's no ambiguity here. And in my calculator, I get 23.3342318. Now remember, these are degrees. So angle A is going to be approximately 24 degrees. Let's see if that makes sense. I'm going to go back to that triangle. So if angle A is approximately 24 degrees, does that make sense? Yes, because side A is smaller than side B. Angle A must be smaller than angle B. Now let's find C. And here we can just use that fact that the sum of the angles are 180 degrees to get our C. And this is going to be approximation because I rounded A. We're going to take the total 180 degrees. We're going to minus the 124 for angle B. And we're also going to minus the 24 degrees for angle A that we just found. And it looks like that would be 32. Let me double check my math. 180 minus 124 minus 24. Okay, so that would be our angle C. Again, I am going to go back to my triangle, put in 32 degrees for angle C, and double check to make sure all those sides and angles make sense. Largest angle, largest side is B. Smallest side, smallest angle, A. The middle would be angle C with side C. So all of this makes sense to me. So now let's look at an application using the law of cosines. In example 2, we have two boats that are leaving a harbor at the same time. They're traveling on courses that have an angle of 105 degrees between them. One boat is traveling at a speed of 18 miles per hour, the other at 20 miles per hour. We want to know how far apart these boats are after 2 hours. So we did have a prior example similar to this when we're looking at right triangles. And in that case, the angle between the boats was 90 degrees. But in the real world, chances are when two boats have an angle formed between them, it's typically not going to be 90 degrees. That would actually be very rare. So I know the angle between these two boats is 105 degrees. Now, in prior problems, we also talked about bearing. Notice that there's no bearing mentioned in this particular example. We're not told that they're going due north at a certain angle. We're not told that it's maybe south something degrees west, because that really doesn't matter in this problem. The only thing that matters is that they're 105 degrees apart. So we have an angle between the two boats, and we have their speed in miles per hour. So that will give us the length of the sides of our triangle. So I'm just going to draw a diagram that represents this problem, and you may draw your diagram a little bit different. So they're starting at the same point, some harbor. One travels, I'm just going to draw something due north. And the other travels in another direction, but the angle between them is 105 degrees. So it's going to be a little bit more than 90. Now that's probably not very accurate, but close enough to where I can see that this angle is maybe 105 degrees. We want to know how far apart they are after 2 hours. I know I'm going to be using the law of cosines formula here, so what I want to do is make sure that I have everything labeled in my triangle. Well, first of all, one boat is going 18 miles per hour, so that would represent one side. But we're supposed to be finding how far apart they are after 2 hours. So in 1 hour, that boat has traveled 18 miles, so in 2, it would be 36. The other boat is going 20 miles per hour. So in 1 hour, the length that is, or that distance it's traveled is 20 miles, but we're looking after 2 hours. So my triangle is going to have a side of 36, an angle of 105 degrees, and then another side of 40. I am going to, and here, this is what I want to find. I want to find their distance apart. So what I'm going to do now is just label sides so that I'm clear about what I'm putting into my formula. I'm going to call the 105 degrees my angle A, maybe the one up top B and C, but it really doesn't matter how you label them. But you do want to label them to make sure that you're putting in the right values for the variables in the formula. That would mean the 36 is opposite angle C. That would represent side C. The 40 is opposite angle B, so that would represent side B, which means that my distance is side A, and that's important because then I know that I have to use A squared equal to B squared plus C squared minus 2BC cosine of A. Putting in all the values, remember B was 40, so this is going to be 40 squared. Plus C is 36, so 36 squared minus 2 times 40 times 36 times cosine of 105 degrees. Maybe I'll do some intermediate math. 40 squared plus 36 squared would be 2896 minus 2 times 40 times 36, 2880 times cosine of 105 degrees. In my calculator, that A squared is approximately 3625.39885. And then square root would give me 60.211,285.07. So in this problem, it doesn't say what we're going to round to. However, all the values were given to me in whole numbers. There were no decimals there. So I'm just going to round that 60.211288507 to 60. And then in my sentence answer, it would be the boats are about 60 miles apart. And if you want to write after 2 hours, that's fine. That is sufficient. Now, the last thing I really want to do is, before we move on, is to just double check if A is approximately 60 miles. Does that make sense? And it does, because angle A is 105 degrees. That's the largest angle in this triangle. So side A should be the largest. Now, if you had sort of messed up when you put your values in your calculator, maybe if you got side A being smaller than 36 or 40, that would tell you that something's wrong. Try to double check your calculator. Or you could see something big, maybe your decimal was off, so you had a 602 instead of 60.2. That would tell you, wow, that answer is really big compared to the other sides. So there's a lot of little checks as we go through these problems. Again, the key is to sketch a triangle and make sure that angle sides all make sense. Let's look at the last type of triangle that we're going to be solving using law of cosines, and that would be if you have three sides. So this would be a side, side, side. And these triangles that we solved in first example 1 and now in example 3, these were those triangles that we ended off with in 11.1. These were the ones that we couldn't solve with law of sines. So now we are solving these triangles using the law of cosines. Now I need to find the angles. I have all three sides. I'm just going to find angle A first, and that's just random. I'm just going alphabetically. But before that, I do want to label, to make sure I'm putting the right values in my formula, the sides. So side 7 is opposite angle A, so that's my A. Side 8 is opposite angle B, so that would be my B value. And then the 2 is opposite angle C, so that would be my C value. And since I'm choosing to find angle A first, I'm going to use the first formula, the A squared equal to B squared plus C squared minus 2BC. And I'm trying to find cosine of A. You could have found any angle first, it doesn't really matter. A is 7, so I'm just going to put 7 squared as, I'm going to write this as 49 right away. B is 8, and C is 2. So if I do 8 squared plus 2 squared, I get 68, 64 plus 4, minus 2BC, that's going to be 32. It's 2 times 8 times 2. And cosine of A. So you don't have to put every single value in there. I just wanted to make sure my triangle is correctly labeled before I start skipping some steps in the formula. Now, if I were to subtract the 68 from both sides, remember, you're not doing 68 minus 32, which everybody wants to do. You're subtracting the 68 first from both sides. Our goal is to get the cosine of A by itself using order of operations. That would give me a negative 19 equal to a negative 32 cosine of A. And at this point, I would just divide both sides by the negative 32. Now that I have the cosine of A by itself, also noticing that these negatives would cancel, then I could use the cosine inverse to find my angle A, which is going to be equal to cosine inverse of 19 over 32. So what's nice about this is whatever answer I get will be the correct angle. If you put in a positive value into cosine inverse, you will only get an angle in quadrant 1. Because that's where cosine is positive. So cosine is positive in quadrant 1 and quadrant 4, but angles in quadrant 4 are too large to be an angle in a triangle. When you use cosine inverse, it's just going to give you that angle in quadrant 1. Now, if you're putting a negative value into your cosine inverse function, you're going to get an angle in quadrant 2. Again, cosine is negative in quadrants 2 and 3, but angles in quadrant 3 are too large to be part of an angle of a triangle. So that's what's nice about the cosine function when you're looking at cosine inverse. Put in a positive value, you're just going to get one angle in quadrant 1. You won't have that thing with law of sines where if you put in a positive value, you could possibly have an angle in quadrant 1. You could possibly have an angle in quadrant 2 because sine is positive in quadrants 1 and 2. So I'm putting a positive value into my calculator. Cosine inverse is just going to give me this one value of about 53.5764, and maybe it's knowing me, I always have to write the whole thing out. 2636. I was going to stop but changed my mind. We're supposed to be rounding to the nearest whole number, so I will round angle A to about 54 degrees. So let's look at this. This would be 54. That makes sense, I guess. We'll have to see when we get our other values. So at this point, you could try using law of sines, but again, I would not. Maybe I'll find angle B, and I'm going to continue using my law of cosines for angle B. That corresponds to the largest side, so whatever my answer is, it's got to be bigger than the 54 degrees that I got for angle A. Why is it so light? Anyway, let's go ahead and use the B squared is equal to A squared plus C squared minus 2AC cosine of B. B squared is 8, so this should be 64 equal to 7 squared, 49 plus 4 for C squared minus 2 times 7 times 2, that should be 28 cosine of B. I will have 49 plus 4 is 53. If I minus 50, oh, maybe I'll write it out. 64 is equal to 53 minus 28 cosine of B. Subtract 53 from both sides. And then divide by the negative. 28 to get cosine of B by itself. And at this point, I would use my calculator to figure out what angle B is. It's going to be cosine inverse of negative 11 over 28. So since I'm putting in a negative value, I'm going to get an angle in quadrant 2. After putting that in the calculator, I get a 113.132, which is in quadrant 2. It makes sense. 3964, which means angle B is approximately 113 if I were to round it to the nearest whole number. Again, I'm going to go back to my triangle to see if that makes sense. Largest side is B, so 113 as being the largest angle makes sense. Last step is to find C. So I'm going to simply use the fact that my angle C is approximately 180 degrees minus the 113 for B minus the 54 for A. And again, it's an approximation. I get about 13 degrees. Double checking my triangle. Does that make, well, definitely, because C is only 2. So having an angle of only 13 degrees does make sense there. Okay. The last thing we want to talk about is finding the area of a triangle that's not a right triangle. We're going to look at two formulas. This first formula is called Heron's area formula. And you would use that if you need to find the area of a triangle and you have all three sides. Now, normally, we would use the area is equal to 1/2 the base of the triangle times the height. The problem with these triangles that we're working with is we don't have the height. And sometimes it's okay trying to find the height. Usually you would split your triangle up into two pieces, two right triangles, but sometimes it's really hard to find the height of your triangle. So using the area is equal to 1/2 base times height formula might not be very easy to use. So if you do have all three sides, but you don't have the height, then you can use Heron's formula. And this is not a formula you have to memorize. So Heron's formula, in order to use it, first of all, you have to remember that the perimeter of a triangle, the distance around, is just adding up the three sides. And in this case, we have a triangle with sides A, B, and C. So if we were to add up the three sides, the A plus B plus C would give us the perimeter, but we want to take half of that. So it's kind of similar to this other area formula that we're used to using. If we're taking half of the perimeter, what we call that is we call it the semi-perimeter. So we're going to use S to stand for semi-perimeter. It's not the same as the S for the arc length formula that we looked at the beginning of this class. So to find the area, you need that semi-perimeter first. But again, if you have all three sides, that's pretty easy to find, as opposed to maybe finding the height of the triangle. And then you would use this formula here. This simply says to find the area, you're going to take the square root of the semi-perimeter, multiply it by the semi-perimeter minus one side, A, times semi-perimeter minus the other side, B, times semi-perimeter minus the third side, C. Now it seems a little complicated, but it's not. In example 4, we have the area of a triangle with sides, and this should be a side as well. Copy, paste, and my typo. So you have these three sides. A is 30.5, B is 68.4, and C is 53.7. I have three sides. The first thing I'm going to do is figure out what the semi-perimeter is, which is my S, and it's going to be 1/2. All I have to do is add up those sides. 30.5 plus 68.4 plus 53.7. And then I'm going to multiply that by 1/2. In my calculator, I get, it's not even going to be an approximation because what's in the parentheses turned out to be even. So I have 76.3, and that's exact. So that's my S. If you did end up with something with a long decimal, you wouldn't want to round it. Go ahead and write it as a fraction in exact form. Now this is going to be a long formula. So we're going to take the semi-perimeter. I'll put the square root on there later, which is 76.3. We're going to multiply it by the semi-perimeter, which is 76.3 minus side A, which is 30.5. And then 76.3 minus B, which is 68.4. 76.3 minus C, which is 53.7. All underneath a square root. Now you could just put this whole thing in the calculator at once, or you could do some intermediary computations, like you could do the 76.3 minus 30.5, which would give you a 45.8, and then the 7.9, and then 22.6. Now, this is actually an exact value, 623, 915.1716. Now, how do I know this is not an approximation? And that just goes back to what I'm multiplying. I'm multiplying 1, 2, 3, 4 decimal numbers. And then if I add up all the decimal places, I get 4. So my answer when I multiply, if it's an exact answer, should answer with 4 decimal places. And it does, so I know that that's an exact answer. However, once I square root that, it will be an approximation. So that is actually the square root of 62395.1716. That's the actual exact value for the area. Once I square root, I am now looking at 789.8830.113. I'm looking at an approximation. And here it says round the area to the nearest tenth, which is 1 decimal place. 789.9. At this point, I would add the units. We were working with centimeters, so this should be centimeters. Area is squared. Okay. So that's Heron's formula if you have 3 sides. But we also have this other formula if you have a triangle with a side angle side. So the thing is that angle has to be between the 2 sides. And then you could use one of these 3 formulas, and that would depend on which side and which angle you have. So all of them require using sine. In example 5, we want to find the area of a triangle with side A, which is 40.5 inches, B is 28.4 inches, and angle C is 123.8 degrees. So let me just draw a generic triangle. It's not going to really need a scale. Notice that with C I have 123.8 degrees. So I have angle C. Side opposite B would be the 28.4. Side opposite A would be the 40.5. This is an example where I have a side angle side. So I can use one of these formulas, and it just depends on what side and what angles you have. Since in this case I have angle C, I'm going to be using this second formula because I have side A, side B, angle C. It's just a matter of plugging these values into a calculator. So your area is going to be 1/2. Side A was 40.5. Side B was 28.4. And then multiply it by sine of 123.8 degrees. Stick the whole thing in a calculator, and you would get 477.8991683. Or you could do it in pieces. You could do the 1/2 times the 40.5 times the 28.4 first, then do your sine of 123.8 degrees and then multiply it by that would be a 575.1, I think, if you multiplied it all out. Anyway, we're rounding to the nearest tenth, so 477.9, and this would be inches squared. So that is it for 11.2.